Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 652, find duplicate subtrees. Before jumping into the solution, I would highly recommend you should read the problem statement and at least give 15 to 30 minutes of thinking to this problem. So let's discuss what problem is asking. That we need to return all the duplicate subtrees root node. That's it. And duplicate subtree is which has same structure and same node value. Let's make a tree and show it to you what I am saying. This, 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 these two are duplicate and these three are duplicate. What some confusion may arise if something like this appears. May arise if you do not read the question properly. They may have similar value, but the structure is not same. It's the left child, it is the right child, so structure is not same, so they are not duplicate. Not duplicate, but these two are duplicate and we have to return just 2 and 4. 2 and 4, but I don't know how this output is generated. No idea. You have to return 2 and 4. Why? Because I have submitted this problem and I'm just returning 2 and 4 and it is getting accepted. So no, so nothing to worry. Let's discuss how to approach this problem. If you see, you are needed to required to store this tree. Why? Because in order to have something to compare, that this structured appeared before, then only you can say that this is the duplicate. Then only you can say that. And which type of structure we will be using is not structure, the traversal is in order. In order, what is in order? Left, root and right. And how we are storing this in order? In order is by unordered hash map or hash map. Why? It is very basic. That also, and vector of tree node star. Why unordered map? Because it will be very easy to store that in order. For this node, what will be the in order is null or null. But we will not be using null. We will discuss it later. But this will be stored in this. Let's discuss string and why this. Why we are using this. For string, let's discuss that only. That null for null. Null for null. Null for null is not a good example. Let's take this only. The tree which can be confusing would be a better. Uh, 1, 2, 4, 2, 4. We discussed that this is not duplicate. That much is clear. But how to convey that to our code, to the compiler, that this is not not compiler, to the computer that this is not the duplicate which we required, is using this. When we print this in order, what we would be using is, instead of null, we would be using opening and closing. So we go over here, and we go over here, we get nothing, and we get this. We return it from 2, from left child gets 4. So for 2 this, and 2 in itself, he has nothing, so bracket close. Now do the same thing for this side. Same thing will be returned, 4, something like this, but its right was null. This, these two are different thing. These two are different thing. But if you write it without the bracket, if you took simple vector, are these two different things? Can you say these two are different things? No, these brackets are required. So that's why we use string, because it is very easy to insert these bracket in a string, and also it would be much faster if we do not use a vector. We can use a vector, but that's kind of uh, not the right way. I would say it is like if you saw the test case and you just make a exclusion of that certain condition that occurs. But this is very much applicable to even new problems. So that much is clear how we are dealing with this problem using these brackets. These brackets are just replacement of null. And also why? Because in order to distinct this much is very clear. And why this vector? So that we are able to insert all these nodes inside it, all these nodes, the root nodes inside it, so that it it is not lost. For example, for the very first time this appeared, so its root node will be entered, and again this appeared, so something else will appear, for example say 5. So when we are traversing the map again in order to get the answer, we can get the answer at the 0th position, because it was the first that started it. So the first who started it should be 2, isn't it? The first who started this pattern was 2. Just return the root as same written in the, you only need to return the root node of any one of them. So that much is very clear. Why? And why in order? In order is easy. That's why. Why in order? In order is pretty much easy to make it fit in our story. So that much is very clear. In order is very much clear, because you want to, let me clear one just came in my mind, which is much easy to interpret, that this left, root, right. I think this is very much easy to interpret rather than root left right, root left right. That's what I think. You can try, you can try other traversal also. They will be working, because it's just the key. It doesn't matter what type of traversal, but what I would suggest, use something that much easy to be what I can say, to be compute, much easy to be compute, and and for yourself easy to debug. So that's why in order you can use any other traversal, because that traversal is storing in the key and everyone is going through same traversal, so the key will, all the keys will follow that pattern, so nothing to worry. But this I also discussed this, and also while discussing that, you may have got the algo. What we were doing is, in order traversal, traversal, make a map. Before that, you should make a map of, as discussed above, in ordered map, unordered map. And while doing in order traversal, just fill it. And while filling it, the key should be made like this. Should be made like this. This are left call. For example, we name the function solve left plus to string our root value plus solve our right. That's it. That's the string. Insert it in the map. Insert it in the map. Whatever the node, whatever the node is having that structure. Which structure? The inordered structure. Same inordered structure. Structure I discuss. Structure like this type of structure, but same. So you just insert it and return that s. Why? Why? Because you have to return it so that we can fulfill the right and left subcalls. Very basic thing. And just, and after doing it in the main, what you can do, what you can do while iterating the map, the second would be the vector whose size is greater than 2, not sorry, greater than 2, greater than 1, which means that it is having duplicate. Just return the first is the root. So that much is very clear, and hope it makes sense. Again, oh, let's try run it. It would be a very long. Let's take this. Let's try run it. 2, 4, 3, 2, 4. What is over here? Map is made. We started traversing for one. This left call went. Left call went for 2. Again left call went for 4. Null, null. So what 2 will be getting is this. 2 in itself. Right, nothing. This. We return this to this. This gets over here. What we are giving back is this, I guess. Now let's go to this. I forgot something very crucial, that before returning we are storing it in the we are storing it in the map for 2. What we were getting is this 2. At that time node was 2. uh, let's see for the one now gets for the left call. Let's make it over here. Left call, uh, 3, is this, again the right call, this, not right, left. This time what we would be getting is this, this is returned to this, the left two. Now this, while this is also present, we just inserted. This key is also present, this just inserted. And for three what happens? We get this, we get this, but still right is left. Now three, it goes to right, it get this. This is mapped, now mapped into the, now this is mapped into the map. Now what was the node at that time? It was 3. Now this whole is returned over this, over to 1, over to 1. Very long, I guess. 1 itself, 4, 2, 3, 4, 4, and this will also be inside the map. Scroll it down a bit. It's very long. 1, 2, 1, 1, 2, 3, 4. Now it is also in the map. Which two are having size more than 2? This one just insert what is present at 0th, 2 and 4. Make the vector return it. That's it. That's how the problem is solved. Now see the code. Let me zoom it. Let's remove this. Yeah, our serialized function that we are making, that structure. Same, doing in order traversal, adding opening bracket, closing bracket, left call, right call, the root call, and before returning it, inserting in the map. And here is our map as discussed, string and a vector of tree no type. And after returning it while traversing it, if second second means that vector of tree node type has size greater than 1, that it means it has the duplicate. Just return it. This is nothing. Just push it inside the result vector of tree node type. Very basic thing. Just submit it and see if it is running or not. Yeah, it is running quite fast, quite fast. So I hope I was able to convey the problem, not the problem, the solution. And see you in the next one. You guys are awesome and you have to do what you have to do. So keep grinding. See you in the next one. Bye bye.